Hello students, how are you all? Today we will see some numericals on lens. Numericals based on convex and concave lens. We will take out the position of the image and the nature of the image. But before going through these numericals, we have to know the signs of different position of object, different position of image, and the height of object, height of image. So many things are there which we call sign convention. First we will discuss about sign convention. Let's start. First of all, let us consider that. Say this is a lens. This L is a lens. It's a convex lens or concave lens, whatever it is. We are considering this as a lens, and this is the principal axis of that lens, X, Y. Before starting this video, you should go through other two videos based on lens. The links are there in the description box. You must watch that videos first. Okay, let us start this now. So this is the lens and this is the principal axis. As I discussed in the previous videos that we will place our object always at the left side of the lens. Means here I am placing my object. So this is my object. O is denoting the object. And I will get the image. I may get the image on this side as well as this side. If I get my image this side, we call it real image. Yes. So this is my image and this image is called real image because it is forming right side of the lens. If the image is forming this side of the lens, I mean this side, then this is the virtual image. Fine. And we need to know that this side is positive side, positive direction, this direction, and this is negative direction. Okay? Now, we will see some terms related to lens which are required for the numericals based on lens. What are those terms? Let's see. First of all, we'll discuss about U. Then we'll discuss about V. Now what is U? U is the object distance and V is image distance. And remember, object distance or image distance always we measure from the pole. Yes, this is the pole from which we will measure the distance of object and distance of image. Now which is the object? This is the object. So this is my object distance, U. So U equal to object distance. Which side it is? This side. See the pole. Which side it is? This side. This is negative side. So my U is object distance which is always negative. Fine? Now, as I told you, you may get real image here. This is called real image and this is virtual image. So if you are getting your real image, that means this is your image distance which is V. So V is my image distance. Now if you are getting your image that side means positive, that is real image or positive, this direction. You can see that. So image distance is positive. Even if you get the image this side, that means this is V now. V. But this is negative side. Negative. So image distance is positive or negative. Negative. So the value of image distance may positive as well as negative. If you are getting positive side, this direction, positive direction, that means real image. So positive means real and negative means virtual. This side, negative, virtual. So if it is your real image, then V is positive. If it is virtual image, then V is negative. Now, if it is a convex lens, then focal length of the convex lens, focal length, you know that focal length means the distance between pole and focus point. Yes. So F means focal length. Focal length. Now, if it is a convex lens, then focal length is positive. If it is a concave lens, then focal length is negative. So positive for convex and negative for concave. Concave. Correct? So if it is a convex lens, then focal length is positive. If it is a concave lens, focal length is negative. And I want to tell you that in numerical, the lens will be mentioned. That they will say you that it's a convex lens and it's a concave lens. And the value, the focal length will not be given. I mean the sign of the focal length will not be given. That you have to give it from your own. That's why I am suggesting you to remember this list. So U is my object distance, V is my image distance, and F is my focal length. Few more terms are there. Now, we have seen the nature of the image. I mean, sometimes we get the image this way. I mean, erect image, correct. Sometimes we get the image this way. Sometimes we get the image this way, which is called inverted. So sometimes erect image, sometimes inverted image. Fine. This is called height of the image. Fine. We will denote it as I, means image height. So I is my image height. Fine. Same way, this is the height of the object. So O is my object height. Fine. I is my image height, O is my object height. And if you see that you are getting an erect image, that means upward, okay, then image height is positive. If you get inverted image this way, that means image height is negative. Here image height is positive. Correct? So image height may positive also or negative also. If image height is positive, that means erect. Erect. If image height is negative, I mean this, then inverted. Correct? Now object height. Object always we place upright, this way, never this way. Always we right, always we place our object upright, means this way. So that means this is always positive direction, plus. So object height is always positive, but object distance is negative. So this is the list you have to remember before starting the numerical related to lens. So what are the terms we discussed? We need to revise it again. U is object distance, which is always negative. V is image distance, which is always positive or negative, both. Positive for real, I mean that side. Negative means virtual, I mean this side. F is focal length. Focal length is positive or negative. Positive for convex, negative for concave. And I is image height. Image height means this is the image you are getting, so this is the image height. So this is image height, which is positive for erect. This is image height, but this is inverted, negative. So image height is positive as well as negative. Positive for erect, negative for inverted. And object height, which is always positive. Now we will start our numericals, but before starting the numericals, you should know all this. So I suggest you to make a note of this. First you make a note of this. After that we will start the numerical. Then we can see those signs and put the values accordingly. Okay? Now let us solve this numerical which is displaying on your screen. First read the question carefully. After that we will solve it. But before solving this, I suggest you, as I told you, to keep a note of that sign convention what we discussed just now. You see that sign convention because it is required each and every step of this numerical. Read the numerical. In this numerical, an object of height 4 centimeter. Object of height 4 centimeter means object height, which we denote by O. So O is my object height, which is 4 centimeter. An object of height 4 centimeter is placed at a distance of 15 centimeter from a concave lens. Object is placed at a distance of 15 centimeter means object distance, which we have denoted by U. So U is my object distance, which is 15 centimeter. Okay? From a concave lens of focal length. From the concave lens of focal length means F. So F equals to 10 centimeter. Fine. We have to find the position and nature of the image. Position of the image means where the image is forming. I mean V, image distance. Correct? Position of the image means image distance, that is V. So V we have to find. And nature of the image. Nature of the image means real or virtual, erect or inverted. What? Understood? Nature of the image means it's a real image or it's a virtual image, or it's an erect image or inverted image. After solving the numerical, I'll show you that. After solving, we can declare those things. First, let us go with this. Now, if you see your list, which I told you before we discuss this, I told you to prepare a list first. If you see the list, you will see that object distance is always negative. I mean U is negative. U is negative. Focal length. Focal length is positive for convex lens. Focal length is negative for concave lens. Which lens is mentioned here? Concave. So focal length is minus 10. Got it? Now O is object height. Object height is plus or minus. It's always plus. So it's plus. You don't have to write plus, but you may write also, no problem. But V we do not know, plus or minus, because we do not know the value of V. We have to calculate the value of V. Now, the question is that, how do you calculate the value of V? I mean image distance. For that we require a formula, which we call lens formula. Lens formula is 1 by V minus 1 by U equal to 1 by F. Let's write it. 1 by V. This is a special formula. This is the relation between image distance, object distance and focal length. This formula is called lens formula. Here we have to put all these values and we will get the value of V. So let's put U is minus 15. What is F? Minus 10. Okay? Now, minus minus plus. minus 1 by 10 plus 1 by 15 is going that side. Now 1 by V, what is the LCM of 15 and 10? 30. 30. By 15 divide 30, 2. 2 ones are 2. By 10 divide 30, 3. 3 ones are 3. Minus 5 by 30. So 1 by V equal to minus 5 by 30. That means V equal to 30 by minus 5. Now, what we are getting? 5, 6. So, we are getting V equal to minus 6. Yes, V is minus 6. Now, so, we can say that the image is forming at a distance of 6 centimeter from the lens. No, we will not write minus, we will write only 6. The image is forming at a distance of 6 centimeter from the lens. And since V is negative, if V is negative, from the list which I told you to make, from that list, if you check, if V is negative, that means it's a virtual image. Yes. So we got image distance equal to 6 centimeter. And it's a virtual image. Why virtual image? Because from that list we know that if V is negative, then it's a virtual image. If V is positive, it's a real image. You understood this? But the sum is not over yet. See the question. Also find the height of the image. Got it? For that, we will use another formula. To find the height of the image, another formula is required. That formula is V by U equal to I by O. Yes. V by U equal to I by O. Let us write that. V by U I by O. Now what is V? Image distance. What is the value of V? Will not write 6. What we got here, the exact value, V is minus 6. So instead of V, we'll write minus 6. By U, what is U? U is minus 15. What is I? Image height. What is image height? That means image size. Image size and image height both are same. So what is image height? We do not know. I by O. O is object height. What is the object height? 4 centimeter plus 4. Now minus cancelled. Cross multiply. 15I equal to 24. So I equal to 24 by 15. 3 5 ja, 3 8 ja. So 8 by 5. 8 by 5 means 1.6. Yeah, 1.6. 1.6 centimeter. Okay. 1.6 centimeter is the height of the image. So image height is equal to 1.6 centimeter. But image height is positive. If I is positive, see the list again. Yeah, I told you that list is required for all the whole numerical. If I is positive, what is written in the list? If I is positive, it's an erect image. So it's an erect image. So you saw the whole numerical. Two formulas are there. Lens formula and this is the formula to find the image height. Now, and also we got the image distance, image height, and nature. Nature means real or virtual, erect or inverted, both we got. It's a virtual image and it's an erect image. I hope you understood. You practice the sum. The sum is easy. Just you have to remember the formula, and the sign convention is very important. I mean those which is positive, which is negative, what we discussed previous portion of this video. So you must remember that and practice it. Thank you.